Okay, this lesson is on graphing parabolas. Now you might think, well, Mr. G, we have graphing calculators and we have Desmos, and why do we need to learn how to graph parabolas when we have graphing calculators that do it for us? Well, there are parts of parabolas that your graphing calculator or Desmos will not show you. You certainly can use the graphing calculator and Desmos to get a visual idea of what the graph looks like. But there are a couple pieces of a parabola that you will not find on your graphing calculator or on Desmos. So we need a little bit of math to figure that out. First off, as you learned in previous lessons, how to put the equation into vertex form. In order to graph parabolas properly and find all that we need to find, it needs to be in vertex form. So let me just remind you what vertex form is. That's y equals ax minus h squared plus k. Okay, the vertex is represented, and this is in vertex form. The reason it's in vertex form is because it actually gives you the vertex. The vertex is simply just h. Okay, that is in h. Okay, so whatever is here and whatever is here is actually the vertex of the parabola. The axis of symmetry, if you remember from parabolas, parabolas are symmetrical in that they have the same exact mirror image point on either side. So in a vertical parabola, the axis of symmetry will be x equals whatever h is. So it's a vertical line. Since the parabola is vertical, the axis of symmetry is vertical, and it's vertical at whatever the h value is. That'll be more apparent when we actually graph them. And one thing to keep in mind is the axis of symmetry is not actually a real line. It's just more of a, if you folded your paper in half, it's that crease you would see. It's not actually a real line. So, direction up or down is determined by the value of a. If a is greater than 0, then it's up. If a is less than 0, then it's down. So basically, if a is positive, it goes up. If a is negative, it goes down. Now, size, we're not really going to talk about size and width because we're actually going to find actual points, so you won't actually need this. So we're not going to talk about width. Basically, the a will also tell you whether or not it's going to be wider than normal or thinner than normal. But that's not important because we'll actually find real points. The next piece here is some new vocabulary. If you're taking this for at least the second time, then these should be familiar terms. At least you've heard them before. But if this is your first time, the focus and the directrix are new terms to Algebra 2. They are points that are not found on any graphing calculator or on Desmos. So these are the things that we're going to have to actually find. Your focus is p distance from vertex. Okay, p distance, that's going to make more sense, like I said, when we get it. P is just a number. P is just a number, and so it's whatever p is, it's that distance from the vertex. The directrix is negative p distance from vertex. So it's the same, just opposite direction. And we'll show you what that means here in a second. The axis of symmetry runs through all of these points. The axis of symmetry runs through the focus. I'm trying to write with my finger here. Focus and directrix. And cuts the parabola in half. Okay. Vertex. Vertex, we already discussed what it is. It's HK. But the vertex is halfway between the focus and directrix. Whew, a lot of words. A lot of words. You have P, distance from vertex, directrix, focus, axis, symmetry, all of these things. It might be easier just to look at what it actually looks like. So if we look at an actual parabola, back in Algebra 1, you are familiar with calculating vertex and then maybe some extra points in here to graph a parabola. But what you're not familiar with are these extra points called the focus, and the directrix is actually a line. Okay, I'm not going to get too much into the math behind what all this means and why we need directrix and focus. That's another conversation that I can have if you're curious as to what the heck a focus and directrix is. Basically, the focus works just like a satellite dish. If you have satellite TV and you've ever looked at your dish is actually in the shape of a parabola, and there's a little arm that comes out called the receiver that goes in front of your dish. Now, because the reason why satellite dishes are shaped like in a parabola is because as the satellite images come off, from the satellites and hit your dish, all these points reflect back to the focus. So essentially the focal point is a collection of all these reflections off of the parabola. So that's why how your dish works. Your satellite dish is taking satellite images. Here I can do a bunch of fingers here. Satellite images here that are coming in and then focusing on this single point called the receiver, and that's how you get your signal. So that focal point can be calculated using a very simple formula. And you can see the P distance here. The directrix will always be opposite in the opposite direction, the same distance. And it's a line, and we usually represent it in a dashed line. So you'll see this as we do some example problems here. Okay, so here is some example problems with graphing parabolas. And up at the top here you have sort of your little key that there's the vertex form. This is the form of a parabola. You have your vertex as HK. And then you have these extra formulas here. Basically, if you need to find P, you use this. If you need to find A, you'll use this. And I'll show you both examples of this. So here's an example of an equation that could be asked for you to graph. Y equals 1/12 x squared. For step 1, we have to get it into vertex form. So if you remember from the previous lesson, vertex form, we have to put parentheses around our x. We then have to look and see this number cannot be anything other than 1. So if it's not, we do have to divide this out. We have to divide by 1/12 out. So the 1/12 will come out, leaving us with x squared. Now, we need room to complete the square. The problem is there's nothing there, so it's just 0. Well, you could put 0x and then plus 0 if you want to do that, and then plus 0 on the outside too. So when we go to write this in vertex form, remember the same number will multiply to be 0 and add to be 0, which is just 0. So the equation looks like this. In factored form, x plus 0 squared plus 0. And that's in vertex form. So that's important because now we know where the vertex is. You probably could have guessed that already. But now we know that the vertex is at HK. And this is HK. So it tells us that our vertex is at 0, 0. So I'm going to go down here. And I'm going to plot a point at 0, 0, and label this my vertex. Okay? Now, we have to find the focus and the directrix, and they are P distance away from the vertex, and we have a formula for that. We have a formula here at the top. It says, because I need to find P, we're going to use this P formula here. P equals 1/4 times A. Now A is the same A as it is in all quadratics. It's this number right here in front, or this number here in front, or this number here in front, 1/12. So what we're going to do is we're going to substitute 1/12 in for A. Now the easiest way to do this is just to do 4 times 1 divided by 12. So get your calculator out, do 4 times 1 divided by 12. If you do 4 times 1 divided by 12, you get like 0.33333333. Don't worry about that. Now, once you have that, you'll just do 1 divided by that. 1 divided by 0.33333. Or a quick button to do, once you have this and you get 0.3333, there's a button on your calculator that looks like this, x to the negative 1. That does 1 divided by whatever you have, like in one, just push one button, that's it. So I can just use this x to the negative 1 button. It's called the inverse button, and that allows me to divide whatever I got into 1. And what you should get is a value of 3. Because it is a positive 3, that tells us that the graph goes up. If this is positive, it's going to tell us that the graph goes up 3. So what that means is the focus, since the focus has to be inside the parabola, the focus is up 3. Whatever you get for P, that's going to tell you where the focus is. And the directrix will always be opposite that, or negative P. So the directrix will be down 3 units. And you can put a point there, but it's actually a line. So it's going to be a dashed line that goes across here. All right, we're almost done. The rest of this now is getting points. And this is where your graphing calculator or Desmos will come in. I have a feeling that most of you are probably going to want to use Desmos, which is fine. But when you go to Desmos, you're going to want to put in this equation. You can put in this equation right here, or you can put in your new equation too, if you want. But either one, I would just do this one. It's just easier. Y equals 1/12 over x squared. When you do y equals 1/12 over x squared into Desmos, it's going to draw the graph for you. And what you can do is a couple things here is you can trace your finger along the parabola to find other points that you can plot. Because right now we can't really plot this. We need a couple points here. So one of the things that one of the points that you might find when you go into Desmos and you're dragging your finger along, try to find whole number points. I know it might be difficult, but you can try whole number points. The other thing you can do too is change your graph or your equation into a table. Once you have the equation into Desmos, you can above your equation in Desmos, there's a little gear. You click the gear and you click table, and it will switch it to a table view, which gives you a bunch of points that way too. But what you should get is 6. You would run into 6, 3. That would be a whole number point. If you didn't find that, trace it on your graphing calculator or trace it on Desmos, and you can find 6, 3. You'll also find negative 6, 3 too. Since parabolas are symmetrical, and I'll sort of just draw this in here. Since parabolas are symmetrical, you will have mirror image points on either side of that parabola. So, and then we just connect the dots, and that is our graph. That is graphing parabolas showing focus and directrix. One thing to keep in mind is that your graphing calculator or Desmos will not show you your focus and directrix. You're going to have to do that algebraically. Now, one thing you might notice in number 2 is it's the same thing. It just has a different a value. So when we put our parentheses around our x's and divide out negative 1/8, we get y equals negative 1/8, and then x squared plus 0x plus 0 plus 0 on the outside too. And then when we go to put this into factored form, it's just negative 1/8 y equals negative 1/8 x plus 0 squared plus 0. So once again, just like the previous problem, our vertex is at 0, 0. So I'm going to go down here, place a vertex at 0, 0. Okay. So this is our vertex, okay? And now I'm going to find my value for p. I need the distance, the p distance. Where p equals 1 over 4a. Here's my a right there, negative 1/8. So I do 1 over 4 times negative 1/8. That'll equal p. And if you do 4 times negative 1 divided by 8, and you get an answer, you'll get negative 0.5. Hit that x to the negative 1 button. Or just do 1 divided by negative 0.5. What you should get is negative 2. The fact that our p-value is negative tells us that the parabola goes down. And down 2 is where the focus is. Since it's negative 2 and our focus always follows our p-value, it will go down 2. So this is our focus, which means that the directrix is the exact opposite, or up 2. Here's our directrix, and it's a dashed line. And now we just need to find points. So again, you go to Desmos or trace on your graph, in Desmos, or change your equation to a table. If you don't know how to do that, if you want to stop your video and come and ask me, I can show you how to do this in Desmos, how you get points. But basically, by tracing along or switching your graph to a table, you should notice that for negative 2 is a point, as well as negative 4, negative 2 is a point. They should be equal distance away, and our graph then goes down. That's it. That's graphing. Now, what if I gave you the vertex and I gave you the directrix? Could you find the equation? That's what we call going backwards. So in this last question, we have them tell us that the equation, write the equation in vertex form of a parabola with the vertex at the origin and the directrix at y equals 3. So an equation in vertex form, first we're going to start off with the equation in vertex form, which is y equals ax minus h squared plus k. Now it tells us that the vertex is at the origin. The vertex is at the origin, which means that the vertex is at 0, 0, 0, 0, which means that our h and our k are 0. So we have y equals x minus 0 squared plus 0. So actually, the only thing that we need to find is our a value. And this is where the other version of this formula comes from, because I need a. Now I'm going to use the other formula. I need a now, so I'm going to use a equals 1 over 4p. So let's go down here. A equals 1 over 4p. So we'll do this. A equals 1 over 4p. So what is p? Remember, p is the distance between either your focus or your directrix. So if we just go over here and we know that the vertex is at the origin and the directrix is at y equals 3, you just look at this y and this y. What's the distance between them? 0, 0, and y equals 3. Well, if you figured that out, the distance is 3. So we know that the p-value is 3. So a equals 1 over 4 times 3, which means that a equals 1 over 12. And all we do is substitute that in. So now my equation is y equals 1 over 12 x minus 0 squared plus 0. The last thing that you're going to want to check is whether or not the parabola goes up or down. The way to do that is by creating a quick little graph of your parabola. And it doesn't have to be anything fancy. You know that the vertex is at the origin, and you know that the directrix is at y equals 3. Just by drawing a simple sketch here, you know that the graph can't go up because it has to go away from the directrix. So you know that it's going down, which tells you that your a is negative. And that is your final answer. Again, please stop me. This is probably one of the hardest things to understand this semester. So if you're a little confused, it's okay. Remember that you do not have to pass every single outcome to pass this class. This may be just one of those things that you're like, you know what, it's really hard. I can focus my time somewhere else. But if you want to get an A and you want to replace it with an A, you're going to need to master all these outcomes. So if you want more help with this, please see me and I'd be more than happy to help you. Thanks.